Hello everyone, in this clip we will talk about the Stream API of the Java 8 JDK. We will discuss these different features of the Stream API, for example, how to create streams from existing collections and arrays. We will also discuss the different methods that the stream offers you, the limitation or the rules that are therefore using the Stream API, and I will show you a lot of examples, for example filtering, mapping, flat mapping, collecting, all the different methods. So for that I created a person class. The person class has different attributes. As you see here, there's a gender attribute, last name, first name, the nationality, the residence, the birthday is a local date, you have a height and a weight and hobbies. So we have lots of stuff that we can work with, and all the examples that we discuss later will be based on collections of persons. So we have always somehow a collection of persons where we want to find some things out, want to print things out. So these are all the use cases. But for the start, we will look here at our playground. And before we discuss and I show you all the different examples that are listed below here, I would like to show you how you actually can create streams. So, for example, you may have a list of, say, person, or whatever other type you may think of. So we have a list of persons and we create this list. And this is empty, but it could be somehow have elements in it. And now we want to create a stream. How can we do that? It's as simple as what we call the stream method here. This is easy. You can do that not only on the list, you can do it on collections and all other things. Sometimes you may have just an array, for example, in integer array. Say we have named I array, and there are some integers in it, but we don't actually need them here, just for the showcase. We have to provide an initializer here. And if you want to create a stream of this array, we can use the utility method from arrays class. And you can use stream, and you can just put in the iArray thing in here, and you will get a stream. So if we call this method, we get a stream. Okay, we get here a stream too. It actually doesn't make sense to store the stream because the stream, every call on the stream somehow changes this value, and you don't need the stream to be somewhere stored. You always chain the calls to the stream, but I will show you later how that works. And at some point there may be you need to concat different streams. So in this case, let's just extract this other stream here to a local variable. We switch this one here from integer to person, so that we actually have the same types here. And then we will get here a person stream. And what we can do is, we actually can create a stream of both of these streams by concatenating these streams via the concat method. So we can provide here stream, and I don't want to create one, we can create a local variable here, and say stream 1, and we have concatenated these two streams. And so all of the elements of the person list and the I array are actually in the stream, and we can do things with them. So this is how we can create streams. There are more ways to create streams. Somehow you can use the files API. If you use files.read all lines, for example. The cool thing is you can actually use this method here. Say I want to read all lines from, say, file here, let's say temp txt. And the cool thing is you can just create a stream here. You can also create a parallel stream. This is for parallel processing. You can run through the stream in parallel, but that's not interesting for now. And so the cool thing is you can just read all the lines of the file and process them in the stream. So each line can be somehow concatenated, filtered, whatever you think of. So this is just for the playground, so that you know how we can actually create streams. I will remove that method here, and we will start looking at some examples. This is a lot easier to talk about. So the first thing, we want to implement this method. We want to print all elements in this person, from this person collection that is provided to this method here. If you don't use Stream API, we would just create a for loop and say for person P persons system out print line person, for example. This would be the P actually. And this would be the solution when you don't use the Stream API. When you use the Stream API, this thing gets a one-liner. So you can say stream for each, and you can just say, if you like the long notation, you can say P goes over to system out print line from P. And this is not the longest way, we can do it even longer if you like. It's the same as person P this here. So you can skip the parents if you like, you don't need them. You can also skip the type because it's inferred. And you can skip even more things. So you can, this one here, just let's go back a little bit. So let's look at the maximum we may use here. This is something like this. This is actually the longest way you can write this lambda expression. But we can skip different things because we don't need all these things. We just need them at some points where we, these type arguments we need almost never, because all the type arguments are inferred from the type of the collection of the persons here. So we don't need them. These one here, the block curly braces, we only need if we need more than one expression in our lambda here. But in our lambda we don't actually, we just need to print out the thing here. So it's just a single statement, and therefore we don't need a block. So we can remove the parents and the semicolon. And we can even provide this one here with just a method reference. So we can say system out print line, and this is exactly the same as before. So this is a shortcut way, because the print line method takes an object. This is somehow the notation you can use, and there's even more a shortcut for each method, because each collection has a for each method actually, and this is the shortest version you can write this one here. So it's really short. And you can print the elements also in parallel if you like. If you want to print them in parallel, you actually have to create the parallel stream. You can't use for each parallel. There's no such method actually. This is the print all elements method here. So let's go to more interesting things. So this one is actually the same as below, but we don't want that. We want it simple, so we don't want to print in parallel. Just want to do it in the normal way. So now we want to sort the elements. but we don't want to sort them by the person comparator. If the person is somehow comparable, it would be easy to sort them in parallel by the comparator, but we want to sort them by the name, and maybe this is not the natural order of the collection type. So what we have to do is we create a stream again. We say persons.stream. We want to filter. There's a filter method on the stream, and what we actually want to filter is if these person filter actually, sorry, no, not filter, we want to sort them actually, and we want to sort them, and we need to provide a comparator. We can provide a comparator because the function interface with a lambda expression, so we want to compare two things, the person 1 and the person 2, and we say person 1 dot get, we say last name. Name is maybe last name. We want to compare the last name and say compared to P2 get last name, and then we want not find first for each actually, and we do the same as above. We say system out print line, and this one actually prints all the elements outsorted by name. So the cool thing is here above here you didn't see that. You might wonder why we don't need a return statement here. This is actually the same as we would write this one here. Parent, but this is the same, but we don't need to provide these. If there's a single statement and the functional interface method actually expects a return type, this thing is actually something like automatically the return value of the statement. So we don't need these here, we can just skip them and we are good to go. Interesting things maybe is all or some operations of the streams, like the sorted method, are actually lazy evaluated. It's an intermediate operation, so the streams get sorted, but if this method here is called, so this one here is called, this sorting hasn't started yet. So if we don't just do if you just skip here and we don't do anything else, then the sorting hasn't taken place. There's nothing happened. It needs a terminal operation like the for each here, or collect, or find methods, or all match methods. These methods are actually needed. These are terminal operations, and terminal operations actually do something or trigger the intermediate operations to get executed, and the intermediate operations can somehow be combined together so that they don't need five times work through or loop through the whole elements to, for example, sort them, then filter them, then map them, then whatever. You can somehow, the compiler can, or the JVM can decide what is might be the best performance thing to do. So let's go on. There are more methods here to implement. The next one is interesting. So we want to find something. So this sounds interesting. We don't want to create a return optional empty. We want to sort of loop through the persons here and find the person with the name that is provided. So what we do is we could build a for each loop, for loop, and somehow go through the loop and find the thing that we need. But we can do better. We can use Stream API. We can just use the filter method. Now it's time for the filter method. We want to find a person. That person should have the name that is provided, so it should be equal to, let's say we want the last name only for the simplicity here. So the filter operation is also intermediate, so it's lazy evaluated, so if we just provide the filter method, nothing happens. So if we filter all the things, and we want, for example, we don't care if it's the first or the last, hopefully we find someone that is that has this name, so we can use, if we want to find the first one, we can use find first. And find first somehow is a short circuit operation, so if the first element is found, then all the filtering stops and no more elements are processed, so maybe you don't have to loop through all the things to get the right element you need. So the cool thing is, if you use even more filter methods, you can use another filter. For example, we want, I don't know, we want the persons that are taller than, let's say, get hate, are taller than 180 centimeters. We can do that also here. The cool thing is, as I said before, the compiler or the JVM tries to optimize this. So what actually is happening is that these two expressions are getting combined together, so that there's only one loop running through this collection, and filtering is better for the performance. And in the end, we get an optional here. So that's it. You can also do filtering in parallel. This is an easy one. We just copy this one here. You can ignore the 180 thing here. Oh, sorry, I just copied too much, I think. Do it again. And the thing is, the only thing we need to change is few persons. Yeah, yes, right. I put a typo in all the methods actually. We don't need this here. And we want to do some parallel thing. Remove this here, and we have parallel stream. The find first method is a good idea, but we actually maybe want to not use find first, because if we use find first and we have a list, then the parallel execution has no benefits actually, because if someone finds, or some thread finds an element in the list, it has actually to be the first element, so the parallel thing doesn't do anything good for you. So we have to switch to find any. Find any, and then maybe there are 1 million persons in this list, and then there are 10 threads, and each thread can search 100,000 elements, for example. Then if someone finds a thing, then it could say, I found something, and all the other threads can abort, because it doesn't matter if it's the first or not. It's just find anyone. Be aware of this fact, please. So there are more examples. I don't want to show all the things, I will just show you another thing that is somehow more interesting actually, I think. We can go to the get all hobbies thing here, and there's also something like a flat map thing. So at some point as you might have remember, is that the person has a list. Each person has a list of hobbies. So we don't want a list of something bad. We want just because if we just copy all the things together, we just want all the hobbies of all persons in one list, not a list of lists. So we can actually do something like person.stream. We have a map method here. But as I will show you, this method doesn't do the thing that you might want it to do in this case here. And we want somehow to collect all the things here in this list. And the collect method I didn't show you actually. The collect method is something when you want to return a list or a collection or whatever, or actually something that you need to collect from the stream. The collect method is the terminal operation, so it's at the end. There's something getting out that's not a stream. So there are already methods in the JDK. A lot of them are in the collectors class. We have something like to list, for example. We want to return a list. So as it says here, doesn't fit because we don't want a list of strings. So this would be okay if we somehow want to return all the, let's say, all the last names, for example. And this one would work. This is how you somehow can transform from a list of persons to a list of strings, for example, by mapping to a special attribute of this person class. More interesting in this case is not the map method, but the flat map method. The flat map method is interesting because it does something like flatten the lists here, and it actually needs it takes a person as an input, and we need to provide a stream of persons as an output. So what we do is we get the list of the hobbies here and call the stream method on. And we are good to go. So now we have somehow flattened all these different lists of hobbies from each person into one big list of hobbies. So there may be duplicates in this list. So let's go to not the next, but the example below that. We may need to filter out duplicates. How can we do that? This is easy. There's just a distinct method here, so we can just say, not here. We need a stream, and then this all things are good to go. Another solution would be not to use distinct here. This could be also cool, but might be not so beneficial. Actually, we need to put the distinct here. I just made a mistake, but it's okay. Because we just don't want the persons to be distinct. We want the hobbies to be distinct. And at this point at the front, where at the stream thing here, we have a stream of persons. Here we have a stream of strings, so we have to be aware of where we put things. So the thing that doesn't get changed is the order of different things. So the map, if the map is defined before another map, then it's actually sure that these are applied this way. The same goes for filtering. But there's a different thing that you could do. We could just use the toSet method here. If we don't care about, we just need to return a collection, so we could just use the set method, and the set method has some duplicates in it, so this would work also. Another thing is maybe we want to filter all the hobbies of women only. So before that, we have to filter something. To filter something, we want to filter on the persons, because if we can, I will show you that it doesn't work on the other side. We have to filter. We want to say p.get gender is equal to female. Here it's okay, and as I said before, you can go here and put in the same thing. It doesn't work anymore because the stream type changed actually. The stream at this point at the end here is a stream of string and not a stream of person. So we have to put it up front the flat map. And then we will get all the persons, all the female persons, and at this point here, and after that we map these female persons to the hobbies. And then we collect all these hobbies into a set. Yes, that's pretty much it. You can also, there are lots and lots of different other methods. For example, if you just want the first, let's say, we only need the first 5 hobbies, we can use limit. You can also use offset to do some paging here, so we can use limit and offset like in the database. There is also something like skip. And you can run through the list and say I don't want the first. Oh, sorry. I don't want the first 5 elements in this list, and then I can say I want to skip the first 5 and collect all the others. So list has not all the hobbies because the first 5 ones are missing here in the set. So that's that. There's also something that I'd like to show you is you maybe want to figure out something that is true for all the things in the list. We can do that by saying something like persons dot stream. And let's say we want to find out if a person is older than 15. What we have to do is you can use filter, but as you see it doesn't fit the approach actually, but just for now I will show you first the criteria here. We have P and say we can use chrono unit here, about years, and say difference, no, between, let's say we want the person's birthday and local date and the current date actually. So, and we want that to be more than 15 actually, or not more than 15, let's say at least 15. And what can we do now is we can count and say, oh, this one is actually the same size as persons.size. Okay, this one works actually, but it isn't so cool. There's another thing. We can switch this one here from filter to, for example, all match. And if we use all match, we can skip this one here, and that's it actually. So this is the thing I want to show you. There are more examples available, and there are lots and lots of different things. You can just think about different scenarios where what you want to do, and you can try to fix that or to implement a solution for that. And I will talk to you in the next lecture on next Tuesday about these different Stream API functions, and we will make some examples there. So be somehow prepared for that, and it will be quite fun to do that. So thanks for your time, and see you next Tuesday. Bye bye.